I'm Colin Walls, and I'm here to talk some more about USB in embedded systems. On this occasion, I want to talk about the layers of software to implement USB and some of the details of using USB for an embedded application. Now, if we take a look at the layers involved, there are basically 5 layers in the USB stack. These are separate on the host and the function. Remember, the host is something like a computer and the function is a peripheral device. And these stacks look similar, but each one is a separate set of software. At the top of the stack, we have the application layer. So this is the program you're running on your host computer perhaps, or it's the application software on the peripheral device, depending which side of the bus you're talking about. Next layer down will be middleware. So this is something like a file system or whatever, which characterizes the kind of data you're dealing with. Probably the most interesting layer is the third layer, the class driver. Now, the class driver is all about defining what the USB device is, what kind of device it is. And there are a number of standard ones available which you can apply if you use a standard USB stack. Here is an example of some of the function class drivers that are available to you. And there are also another bunch here of host class drivers. And something quite important is to make sure your device looks like one of the standard devices. Now, you can write a custom class driver, but I wouldn't recommend it, because if you create a class driver for your device, then you need to produce one for a host as well. And that means you need one for Windows, one for Mac, one for iOS, etc., etc. So if you can make your device look like a standard USB device, then the standard host class driver will do the job. On to the next layer. The next layer is the protocol stack itself. This is where all the clever stuff of USB is carried out, and you don't need to know the details, you just need a separate stack, as I said, for the host and the function. And lastly, at the bottom of the software layers, we have the controller driver. And again, these will be available for all the standard USB driver, USB hardware that you'll come across. So that's what the software stack looks like. If you purchase USB from any standard vendor, it will be structured in this way. Now let's think a little bit about using USB in embedded systems. Now, chances are you're going to be creating a device which will be connected to a computer. So you're probably creating a peripheral of some kind. Now, if you're creating a peripheral, then you will need a USB function stack to run on that device. There is an alternative, and that is you might be creating a host. Now, you won't be creating a PC, I wouldn't think, but you might be doing something like a set-top box, in which case you need a host USB stack to run on that device. Now, sometimes a device doesn't really fit this model. It's a device which might sometimes need to be a host and sometimes need to be a function. A good example here is a camera. A camera will need to be a function when it talks to the computer for uploading photographs, but it might need to be a host if you connect it to a printer to print the pictures. There are 2 ways you can address this issue. One is you can simply put both stacks on your device. You can put a function stack and a host stack. You'd need separate connectors for that. It's all rather complicated. So there is an interesting alternative. And the alternative is a variation of USB protocols called USB on the go. This has been around for a while. It's gradually increasing in popularity. And the broad concept is a device which supports USB OTG will alternate between being a host and being a function as and when necessary on demand. So that's pretty neat. And I think we're going to see USB OTG much more commonly in the future. Just to wrap up, I want to talk about a few of the technicalities and challenges with using USB for embedded. Firstly, there are the technical challenges. The protocol is fairly complex, and having implemented it, you need to ensure compliance with standards and interoperability with other devices. The simplest part of this is not to implement it yourself, simply license a USB stack from a reputable vendor. The other aspect of USB challenges is the commercial ones. It costs money. You can get all the information you need about USB from USB-IF. They will issue vendor IDs and product IDs. A device needs both of these. A vendor ID will cost you a couple of grand. There's a way around that. Some USB hardware vendors have purchased a vendor ID and will let you use that and issue you with product IDs. So that's an option which can cut costs. If you want to use the USB logo, well, that's another couple of grand. That's life, really. Everything involves costing money. It's not that much money if you're building a device which is going to sell in large volumes and you do need USB functionality. So that's it for USB on this occasion. At some point in the future, I'm going to talk about USB 3 and USB 3.1. So look out for that, and I'll see you on that occasion. Bye for now.